right? At the very end,
Yes.
were we on the group activity?
I think T-scores.
T-scores. No, we haven't gone past T-scores. Have we done proportions? Had we done this slide? Yeah, we're on this, right?
Yep.
Alright. I will give you a bit of a review before I leave you to it. So on Thursday, we will be having your homework due. We will be doing a review on Thursday. And we will be doing an exam next Tuesday. Right, Alright, so I'm going to review a minute so in case you forgot what's going on. Alright, let's get started. We are on chapter 8. It's the last new material before the exam, and we're talking about confidence intervals, right? And first I said that it's always a sample, statistic, plus and minus a margin of error. Okay, and so we did x bar plus and minus, and the margin of error was z alpha divided by 2 times this times this. That was one formula. This was the other formula. Okay, so when it says x bar, by definition, this is quantitative data, right? It's means. Quantitative data. When do I use which one? When am I allowed to use this formula?
Underlying population association, you are given data, or
Sigma.
And number 2? And number 3? Okay, if one of those 3 things is true, these are ors, right? That, or that, or that, then you can use a z-score. Do you agree? When can I use, so that arrow should look like that. This should go then. When do I get to use this part? If my sample size is more than 5% of my population, I get to use that. Do you agree? Okay, if it's a mean question and none of these 3 apply, I'm going to have to use this. Is this a reward or a punishment? It's a punishment. So honestly, usually I wouldn't, right, I've taken a bad sample, I'm probably not going to get this reward, am I? So these don't usually go together. Okay, there is a time when I can use a z-score, but I don't have sigma. When would that be? If n's more than 100, right? If n's more than 100, so that could be an s, couldn't it? And this could be a sigma. When? When do I have to use a t when I have sigma?
when it's less than 30.
When my sample's less than 30, right? When my sample's less than 30, even if I have sigma, I have to use a t-score, right? So, but I just didn't want to confuse you by writing 4 different formulas down for the confidence intervals for means. I just wrote down 2. Okay? So then, I'm going to lay that back then. I think this one looks good. Then we talked about, oh, look at that nice marker. Proportions. Okay, so still a sample statistic, in this case, p-bar, sample proportion, plus and minus a margin of error. Okay, it will always be a z, but you do have to prove it. And then this So this rule, right, this rule doesn't change, right? The rule for the finite correction factor is always the same. You get to use the finite correction factor if your sample is more than 5% of the population. What is the rule for the z-score for a proportion? What's the rule? There's only one. There's no 2 and 3, there's just one.
Oh, isn't it?
Right? N times P is greater than or equal to 5, and N times 1 minus P is greater than or equal to 5. If that's true, you can use a z-score. If it's not true, what? Do you use a t-score? No, you never use a t-score with proportions. That's why that formula is not listed. I haven't got a p-bar plus and minus t. That's not possible. It's a binomial question. If this is not true, it's a binomial question. In chapter 5, when I told you I went to the mall and I stopped 3 people to ask them if they had a dog at home, right? I stopped 3 people. I told you 60% of the population has a dog at home. If you look, n times p is 1.8, and n times 1 minus p is 1.2. This is not a z-score question. This is a binomial question when I talked about going to the mall. Okay. When this is true, we're allowed to assume a normal distribution. So you're going to do 2 problems on the board, 31 and 36. It says in your packet, I think 38, but I changed it because it's got like ugly numbers with repeating decimals that you have to keep trying to use. So I made it to a different question. All right? So here is going to be the first question. A simple random sample of 400 individuals provides 100 yes responses. A says, what is the point estimate of the proportion that would provide yes responses? B says, what is your estimate of the standard error of the proportion? And C says, compute the 95% confidence interval for the population proportion. Okay, so give it a whirl. Get up on the whiteboards and show me your stuff. Ron's like, oh.
Tell me to, but I'm
No record.
Your standard error is not right. It's written right. So p-bar's 0.25, right? You're trying to find an interval in which the population proportion. All right, let's just talk about this for a minute, then I'll pull up the next question. What is this part called? Okay. This part is the finite correction factor. What is this part called? What is this part called? Okay, and then if you add them and subtract the margin of error to p-bar, you get the confidence interval. If you do p-bar plus and minus the margin of error, you will get the confidence interval. Okay, so this is the finite correction factor. When do we get to use it? If n is more than 5% of big N. Okay? And so Then, so when you did the point estimate, you should have just got this, right? The point estimate, give me one number to represent the population number. So you would say 0.25. That's your best guess. That would be your answer to A. Give me one number. What do you think the population proportion is? Well, my sample proportion is 0.25. Therefore, I guess the population proportion is also 0.25. That's your best guess. B, what is the standard error of the proportion? So I'd only be interested in this bit. Okay, you do not have big N, therefore you cannot use that part. So for the standard error, all the answer to B is 0.0217. Because B asks for the standard error, not the margin of error. Okay. Then C says compute the confidence interval. Out of the 1, 2, 3, 4, 5, 6, 7 groups, I think I only see 2 groups who did a proof. The rest of you just started using a z-score. You got to prove that n times p is greater than or equal to 5 and n times 1 minus p is greater than or equal to 5. You got to prove it.
So in P for this problem would be the 0.25.
Yeah, the p, yeah.
Okay.
Okay, so don't forget your proofs before you start using z-scores. Well, not in chapter 6, you're told it's bell-shaped, right? But in chapter 7 and 8, you can't use z-scores without proofs. Okay, so now we're going to do, in your packets it says 38, but we're going to do 36 because the numbers are nicer. I don't think it is a homework question. So this is your next question. This is more of a story problem. And oh, I'm actually adding and changing it. I like the story better because the numbers are nicer, but I want more parts to it. So part A, and so it says, according to statistics reported on CNBC, a surprising number of motor vehicles are not covered by insurance. Sample results consistent with the CNBC report showed 46 of 200 vehicles were not covered by insurance. So A is going to stay the same. What is the point estimate? Okay, I'm going to add a AA. It's going to be what is the margin of error, and B, I'm going to change it to 92%. Because you guys keep writing 1.96, but I'm not sure you know how to look stuff up. So I'm changing that B to 92%. Okay?
Okay.
Look at
Plus or minus
My calculator.
There you go.
Thank you.
Well, just do this one. Yeah, so I can get this here. And then have this.
Are we?
No, it's not going.
I agree with everything that you wrote, but you rounded your standard error on that way. You put 0.0298, right? That was rounded because it was really 0.0297575352. So then when you multiply that, now your margin of error is off a little bit. It should be 0.0521. And so that, and then don't put a bar in the confidence interval.
Oh, don't?
No, because we know what P bar is, right? We're trying to find the interval. So when you write your final answer, you write P, not P bar, because we know what P bar is. We're trying to find the interval for P.
So you subtract 0.23 from that.
The entire number.
Oh, I probably said.
That's why I thought it was weird when I
So
looked.
0.23 plus and minus 0.2 was I'm going to ask you, well, I'm going to tell you a little bit about the exam, and then I'm going to start asking you some questions. So remember on Thursday, I am going to be reviewing for the multiple choice section of the exam. the best way to study for the multiple choice section of the exam is to review your PowerPoints. Okay, but you can't memorize stuff, you have got to understand it. So the exam is worth 20% of your grade, 200 points. Like the first exam, there will be 20 multiple choice questions worth 4 points each. So like the first exam, 80 of the 200 points, or 40% of the grade, is on multiple choice. It tends to be more theory than calculations. Okay? Different than the first exam. The first exam had 6 questions that were equally weighted, 20 points each. That is not the case with this exam. Okay? There are, it doesn't lend, the material doesn't lend itself to have equal weights. So I would tell, if you remember, chapter 5 was about discrete probability distributions. Who remembers what discrete means?
Whole numbers.
Usually whole numbers, right? So it is about how many customers came to your store, how many cars came to the drive-through window, how many bank accounts you opened, how many televisions were sold. That's discrete data. What's a probability distribution?
Continuous data.
No. We're doing, chapter 5 is discrete probability distributions.
Probability of the outcome.
Yeah, so if you had a discrete probability distribution, it's list all the values of x and their probabilities. So we did a question about televisions, right? And it was something like, I'm making these numbers up, but we were given the data. Like there were 80 days when we sold no televisions. Let's say there were 70 days when we sold 1 television. There were 40 days when we sold 2 televisions, and then 10 days when we sold 3 televisions. And we were able to use the relative frequency method, because this was 200 days. This is 80 divided by 200 is 0.4, 0.35, 0.2, and 0.05, and this sums to 1. So if you list this x and these probabilities, that's a discrete probability distribution. This is a regular discrete because we had to be given the numbers in order to come up with that, right? There's no way for us to know how many televisions were sold other than that. So in chapter 5, it was on discrete probability distributions. One was on regular discrete, okay, and we did it about an example in class together about selling televisions. Then we learned about 2 special types of discrete probability distributions. One was binomial, and the other was Poisson. So with regular, okay, you could have been asked to find this, but it's very easy to do this, right? Some questions they even give us this. So you could be asked to come up with the probability distribution if you were given x and the frequency count. You could come up with the probability distribution. You could then be asked to come up with the expected value, which is also the mean, okay? And that is the sum of x times f of x. So in this case, right, we'd have done 0 times 0.4, 1 times 0.35, 2 times 0.2, 3 times 0.05, and I'd say, okay, the expected value is 0.9. Okay. We also calculate the variance or standard deviation. Okay, the standard deviation is the square root of each x minus the mean squared. These are formulas on your sheet. But that's what you could be asked to do with a regular discrete problem. Come up with the probability distribution. What's the expected value? What's the standard deviation? With a binomial, you can be asked to come up with a probability distribution. All I need to tell you with a binomial question is n and p. If I say to you, n is 5, and P's 0.4, and there's some story that leads you to believe it's binomial, I can say, give me the probability distribution. That's all I have to give you. And you can tell me what are the possible outcomes for this binomial distribution. What are the possible values of x in a binomial distribution?
0 to 5.
This one's 0 through 5. The rule is 0 through n, right? And I know this is not a z-score question because n times p only equals 2. And n times 1 minus p is 3. Okay, so how would I find the probabilities? Well, you have a kind of ugly formula that you could use, the binomial formula, or you could go to your booklets, your tables. I'm going to give you a packet of tables on the test. So I'm going to give you a packet of tables, and you can go to the binomial table. N is 5. Okay, N is 5. P is 0.4, and I could copy this down. I went off one. 2, 3, 4, 5, 6. What do you think this sums to? 1, right? So this would be a probability distribution for n is 5, p is 0.4 when it's a binomial question. I could ask you for the probability distribution. I could say, what's the probability? X is 2. And you would say 0.3456. And I could say, what's the probability? X is no more than 2. Then it would be these added together, right? And you could go look on the cumulative table. Or I could say, what's the probability? X is more than 2. And you would add those together. Okay, that's a binomial question. I could ask you probabilities. Okay, I could ask you what is the expected value. The thing is, I could do what I did earlier. I could do an x times f of x column and go 0, 0.2592, 0.6912, right? I could multiply and do it. But what do we know about binomial? The expected value is n times p. 5 times 0.4, which is 2. Right, if I did all this multiplication, this would come to 2, because that's the expected value. And we also know a shortcut for the standard deviation is, and these are formulas on your sheet, n times 1 minus p, n times p times 1 minus p. Okay, so that would be a shortcut if you know you've got a binomial question. Poisson is still still a discrete, okay, but it's to do with time and space. So it would be, what's the probability you get 10 phone calls in the next 15 minutes? What's the probability 8 people go through security in the next hour? Okay, and so it's to do with time or space. So still discrete is counting people or road signs, but to do with time or space. Okay, that's chapter 5. There are 3 short answer questions on chapter 5, 1 on each, not necessarily in that order, but if you haven't noticed, I think I've told you before, in the short answers, I give you the chapter 5 questions, then the 6, then the 7, then the 8. I don't mix them up for anyone, because you know, you guys look like you're all sitting kind of tight, because I think the statistics is logical, and it each builds on the chapter before. So Unicorn, you would be at a disadvantage if, because you sat there, I mixed them up, and yours was like chapter 8, then 6, then 7, then 5. That would put you at a disadvantage than your neighbors who had it all in order. So you all take the same exam. It's in order. Okay, so chapter 5 will come first. Not necessarily in these orders, but all the chapter 5 questions will come first. You will determine. So they're not all equally weighted. So there's going to be 3 questions from chapter 5. There's 1 question from chapter 6. It's worth more points, that 1 question, than these, not added together. I mean, added together, these are worth more than the 1/6, but this one question is worth more than any of these individual questions. There's one question from chapter 6. Chapter 6 was continuous probability distributions, and that's when we were told it was bell-shaped, and we did all the draw and shade, calculate a z-score, look it up in the booklet, find the area that you're looking for. Okay, you have a whole, you can print out that chapter 6 handout again. If you didn't finish it, you can finish the one I gave you. It's on Canvas, as are the answers. Okay, so there's one question from chapter 6. In chapter 7, we went to sampling distributions. So in chapter 6, it'd be, what's the probability a student takes more than 90 minutes for their exam? In chapter 7, it would be, you have a class of, you take a sample of 10 students. What's the probability their mean is more than 90 minutes? Okay, so in chapter 7, we did sampling distributions of X bar, and we did sampling distributions of P bar, but there's only one question. There used to be 2, but the exam was too long, so I took one out. So there's one question from chapter 7. Remember in chapter 7, I said, you all understood 6, so we're going to do a little bit of work up front, and I'm going to get you back to a chapter 6 question. So the little bit of work up front was, we had to prove the sampling distribution was bell-shaped with those things we wrote on the board earlier. The underlying population is bell-shaped and sigma's given. N is greater than or equal to 30 and sigma's given, or N is more than 100 for means. A sampling distribution of P bar, the only proof is N times P is greater than or equal to 5, and N times 1 minus P is greater than or equal to 5. So in chapter 7, you're going to do a proof that the sampling distribution is bell-shaped. You're going to draw the bell and mark on the mean or the proportion, and you're going to calculate the standard error. Okay, you're going to take the standard deviation and divide by the square root of n if it's a mean question, and you'll decide whether or not you get the privilege of using the finite correction factor. Okay, you must use it at least once during the exam. If you get to the end of the exam and you have not used it, I suggest you go back and look, because you need to use it at least once. Once you've done that setup, the proof, the drawing, and the new standard error, it's just like a chapter 6 question. Draw and shade, calculate your z-scores, look them up in the booklet, and find the area that you're looking for to do the probabilities. One question from chapter 7. 3 questions from chapter 8. Okay? And they might have parts like these did, right? A point estimate, a standard error, a confidence interval. A point estimate, a margin of error, a confidence interval. Or it might have a confidence interval for 90%, a confidence interval for 95%. There's one on means, there's one on proportions, and there's one on the required sample size. Remember we said, oh, that is, if we want to say that we want the margin of error to be this, how big of a sample do we need to take? So there's 3 questions from chapter 8. Okay, so if it asks you how big a sample, what it means is you're going to look for a formula where you're going to solve for n. Okay? That's what's on the exam. There are 8 short answers. There isn't time, and remember that they're not all weighted the same. So don't spend and they tell you by each question how many points each question is. So don't waste a whole bunch of time on one question, especially if it's not worth the most points. Okay? So some of them are worth as little as 10 points. Okay, and the most is 20. The most is a 20-point question. But the least is a 10-point question. No, an 8 point. So some are 8 and some are 20. And I will tell you, like the second to last one is 8 and the last one's 20. So you don't want to get hung up on the 8-point question and never get to the 20-point question, for example. So don't get hung up. What I would do is I would do my multiple choice, answer every question, even if you don't have any idea. Circle something, put a star by it to come back. Go through your short answers. And then loop back around, especially those multiple choice you were a bit iffy about. See if there's any work you've done in the short answers that would help you answer that multiple choice, such as the sum of f of x equals Right, and say, oh, there's one, I've got an example right here. Okay, so make sure that you do that, all right? There is 2 reviews this week led by the amazing Stephen Force, who has been there in the past. Okay, and how was it? Good? Yeah, help with the short answer stuff, right? He's really good. So he has one tomorrow at 1:30 to 3, and he has one on Thursday from 1:30 to 3. So it will be like right after the in class here on Thursday, we do the multiple choice, and then you can roll over to BUS 103 and he would go over short answers. There is a review packet online in Canvas with the answers too, right? There's also in Canvas, so as I said, in chapter 6, the handout I gave you in class that we worked on, that's there if you want to practice it again. I added in chapter 7 in here, okay, I have added some extra practice questions for chapter 7, and the answers are there. Okay, and then in chapter 8, I've mixed 7 and 8 together because some students get confused. So if it helps you now just to try and have to distinguish what you're having to do. So I've added some chapter 7 and 8 questions and the answers, as well as having a review for exam 2. Okay, so there's lots of practice for you here. The only one I'd say there's not as much practice for is chapter 5. So if you are wanting more practice on chapter 5, just so that you know how our book works, since you don't really have a paper copy and sometimes that's hard, is, let's see, let me get back to, I don't know the chapter contents. So when you go to chapter 5, and you'll see the categories, the sections of the chapter here. Smaller. Okay, so chapter 5.1 is random variables. 5.2, discrete probability, and then the expected value and variance. We did not do 5.4. Okay, so don't go click there. We did binomial, we did Poisson, we did not do hypergeometric probability. So what you do for the bits you want to, let's say you're confused about when to use what formulas. The applications are always the story problems. Okay, so let's say I'm not sure about when something's binomial. If you click here, right, we did that question in class, let's do another one. Right, what I would do is pull up a question. Now you know this is in the binomial section, so you know this is a binomial question.